Hello, chemistry students. Today we are continuing our lessons on nomenclature. Specifically, we are looking at elements E and F, where we are writing the formulas and the names for ionic compounds. Type 1 ionic compounds are what we are working with today. Both binary, which binary just means 2 elements, and ternary, which means 3 or more. Those are our polyatomics. So just make certain that you know what ion each of our representative elements form. It's a nice, lovely pattern where we kind of count up for each of our tall columns all the way to 4. These are positive charges because they are losing their electrons. And then when we get to group 14, it could be either or, with carbon, my nonmetal, being a negative 4. My metalloids don't form ions, but my metals will form that that positive charge, sorry. And then once we're at 4, we're going to start counting down. So -3, -2, -1. Knowing these charges will help you immensely in writing the formulas, whether it be from the ions themselves or from the actual name, which is what we're going to see today. So yesterday I actually gave y'all all the ions for your practice, but I figured today we'll practice just with starting to determine what charge and what ion everything forms. So if I notice barium is in group 2, it forms a plus. Holding my pen wrong. It forms a +2. Bromine is in group 1, group 17. Wow. It forms a -1. When we're writing our formulas, remember that our most metallic element has to go first, which is typically the thing that has that positive charge. Notice these 2 ions do not cancel out. They cannot reduce. So that means I have to swap and drop. My chemical formula would be BaBr2 because it takes 2 bromines to balance out that 1 barium. This thing's name, well, we name it in the order that we wrote it, barium. And remember that that second element, if we have 2 capital letters, always changes its ending to IDE. So bromine becomes bromide. So looking at the next one, we've got our nitrogen, which is a -3. Thallium, which is TL, is a +3. Well, my positive ion, my metal goes first. My nonmetal goes next. Notice these charges cancel out. They're both the same number with opposite signs. So we only need 1 of each, which means my formula is TLN. And how do I know that's an L and not a I? Well, I's have a dot. So TLN is my formula. The name is thallium nitride. Because with 2 capital letters, that ending must be IDE. All righty, my next one, lithium. Lithium, looking at my periodic table, forms a +1. Nitrate, we saw that the things that were TEs yesterday were my polyatomic. So I take and I look at my cheat sheet and I see that nitrate is NO3. NO3 -1. Sorry about that, ladies and gentlemen. So we've got a +1 and a -1 that cancel each other out. My metal is written first. So my formula is LiNO3. With or without the parentheses, it does not matter. In fact, you could even take and swap and drop the ones if you really, really wanted to. You're going to get to the same place because chemists are lazy and they don't write ones. But either one of those would work. And the nice thing about this is that's its name. Since it is a polyatomic, we don't mess with its special name. It is lithium nitrate. So phosphite, it ends in that TE. That tells me that I'm looking at a polyatomic, which is PO3 -3. Magnesium is a +2. So my magnesium is my metal. It must go first. My polyatomic goes next. And these ions, these charges can't reduce. They don't cancel. So we swap and drop. So the 3 from the polyatomic ends up beside the magnesium. And the 2 from the magnesium ends up outside that polyatomic. This thing's name is magnesium phosphate. Alrighty, last but not least, I'm going to start with a thing that I easily recognize. That TE tells me I'm looking at a polyatomic, which is silicate. And I always have issues remembering this one, SiO3 minus 2. Ammonium, if I look at the front of my periodic table, I don't see anything that begins with ammonium. It happens to be the one positive polyatomic that we will play with that actually forms compounds. It is NH4 plus 1. So I don't really have a metal, but I do have that cation. So that cation is the thing that has to go first. We still swap and drop even though it is 2 polyatomics. And if you won't, you could put parentheses around both sets of polyatomics to make it obvious what you are moving where. So that 1 ends up outside beside the silicate. That 2 ends up beside the ammonium. The charges cancel out. They balance. Therefore, we do not write the charge. I end up with NH4 with a 2 outside of it, SiO3. And since there is just a 1, you don't necessarily have to write the parentheses. You don't have to write the 1, but if you want to, Ms. Raines will not count it wrong because it is the same thing. It's saying that you've got 1 silicate to balance out 2 ammoniums. And since this is 2 polyatomics, we don't mess with either of the names. So ammonium silicate. That was what we saw yesterday with just kind of one little added piece because we were using the element to figure out the ion, the polyatomic to figure out the ion. Well, today's skill is basically going backwards. And the nice thing is getting the name from the formula you kind of already have seen because you've seen how to balance the charges. So when I give you that name, first thing you want to do is you want to look at the name and figure out, okay, well, do we have polyatomics or not? Well, if the name ends in an IDE, that means we're going to have 2 elements. 99.9% of the time. Yes, we saw that there were a couple. Actually, I think there's just 1 polyatomic that has an IDE in it. That's cyanide. If the name ends in a TE, whether it be ATE or ITE, it is a polyatomic, which means 3 or more elements. So once you figure out what elements you're working with, well, then you're going to write their ions. You're going to write what charge each of the elements are the polyatomic forms. And then you're going to balance your charges. So remember, by balancing charges, we have to ask ourselves, can they reduce? Do they balance? If they do balance, we just write the letters. If they can reduce, we reduce. But either way, we end up with our swap and drop. Where's my little, there we go. Swap and drop. So make certain you swap and drop the ions. Once you've reduced, you swap and drop. Now, guys, we are talking in code. We are talking in abbreviations. So it is important that you use the letters correctly. The size and the shape of the letter matters. Big C, big O, big S stands for one thing. Little C, big C, little O, big S stands for something completely different. So pay special attention to how you write your letters, not only to the size of the letters, but the shape of the letters. So like sodium has to be big N, lowercase, little a, not big N, big lowercase a. That is not sodium. That is not correct. We are talking in codes. We got to make certain we're all speaking the same language. Additionally, those of you who are choosing to do the Google Doc version of the assignments, please, 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 to get all of your points, use subscripts on your chemical formulas. You must have the subscript there. Without the subscript, you're not going to get full credit because you're not saying what you think you're saying. So let's look at a couple examples, and I honestly don't know why one of my little clicky thingies isn't clicking right, but that's fine. Whatever. It is what it is. Lord of mercy, my cats are going crazy. Yeah. Six. Okay. Well, they're going to be out of order anyways, but whatever. So I'm going to do the first three with you, and then I'm going to ask you to pause the video and try the next three on your own. So looking at number one, we have a name that ends in IDE. That tells me we're looking at two elements. So sulfide would be sulfur, and sulfur forms a -2 charge. Strontium is in group 2. Strontium forms a +2 charge. So those charges could either think of it as reducing because they're both 2s, they're both divisible by 2, or you can think of it as them canceling out. Either way, my formula, I'm going to end up with 1s beside my letters because we have to write the chemical formula based on the lowest ratio of atoms that equals 0. So all compounds are neutral. Well, a +2 and a -2 already equal 0. So I just need 1 atom of each. And yes, I know we don't have to write the 1s. So looking at number 2, we've got magnesium. Magnesium is in group 2. It forms a +2. Cyanide ends in IDE, so we would think it's an element, but we look all over our nonmetals and we don't see anything that begins with a cyan. So that means it's got to be a polyatomic. Basically, if it's not on the front, it's got to be on the back. You're more than welcome. Well, I say back because I'm used to using the laminated ones, but whatever. It's on your polyatomic sheet. It's good habit to, if you're not confident, check polyatomics first. Because if it's not a polyatomic, it's going to be that non-metal, that second element. So cyanide is Cn-1. So my charges can't reduce. They don't cancel out. So I must swap and drop. And even though that there's no little subscript beside my cyanide, I still want to get in the habit of putting those parentheses around it. That way, when I go to write my formula, I end up with my 1 magnesium and my 2 cyanides. It takes 2 -1s to balance out that +2. So 2 cyanides, you've got to have the parentheses around that polyatomic because of that 2 outside. And yes, you could write that 1 beside my magnesium. Alrighty, looking at number 3, it ends in IDE. Therefore, it should be an element. Well, phos looks like phosphorus, and phosphorus is a -3. Potassium, its symbol does not match its name. Potassium, I always think special K, like the cereal, because it has potassium in it. So potassium is a +1. Phosphorus is a -3. They can't reduce. So I swap and drop. My formula would be K3P, or if you really, really wanted to, K3P1. So pause the video. You try the next 3 using your real periodic table and your real polyatomic ions. So number 4, it ends in a TE. TE tells me we are looking at polyatomic. So carbonate, it is over here with that -2 charge. CO3, -2. Just going to go ahead and slap some parentheses on it. Lithium is in group 1. It forms a +1. Charges can't reduce. They can't simplify. They don't cancel. So we swap and drop. And my formula ends up being Li2CO3. And since there's only one of the carbonates, you don't have to put parentheses. But again, you could if you wanted to. If it helps it make more sense for your brain, just go right ahead. Number 5, cesium oxide. Cesium is in group 1. And I almost used the wrong symbol, CS. Oh, scribble, scribble, scribble. Big C, little s, +1. Oxide, oxygen with a -2. So swap and drop. We end up with CS2O or CS2O1. So last but not least, we got indium. Indium is in group 13. And phosphite, that is a polyatomic, PO3 -3. Look at my charges. Can they reduce? Well, yes, they're 2 3s, so they're both divisible by 3. Do they cancel? Yes. So since they cancel, I can just write the symbols. I don't have to worry about that swap and drop because in a sense, I'm swapping and dropping ones. So IN, I got one of them. PO3, I have one of them as well. And yes, since there's only one, you don't have to write the parentheses. Both of those would be the correct chemical formula for indium phosphate. So guys and gals, my formulas, notice they all have subscripts. They don't have any charges, no positives, no negatives, no exponents. They all have the same kind of layout. So this is our type 1 ionic names to formulas. Hopefully you find this a bit easier than what we saw yesterday, simply because we're re-seeing some of the stuff we saw yesterday. Now tomorrow we will actually learn and see how to deal with our transition metals and our group 14 metals. So I don't know if you've noticed, but I have deliberately, dang it, left the transition metals and the group 14 metals off. And we will actually end this lesson with showing you some examples of some of the names for our type 2 ionic. And with Miss Raines asking y'all to get those Roman numbers into your notes because you will need them come tomorrow. But we're ending up today. I'm just looking at those type 2s and noticing what is the same from what we've seen on Monday and Tuesday versus what is different. And I can't stop the recording because I've hid the recording thing from me. There we go.